geometric related problem. So it says a convergent geometric series consisting of only positive terms has a first term a and a constant ratio r, and n term tn, such that the sum from n equals 3 to infinity of the nth term is equal to 4. When they say converging, that means their sum to infinity is approaching a certain number. That's what they're saying. Eh? Okay, cool. Now, they're saying if t1 plus t2 is equal to 2, write the expression of a in terms of what? In terms of r. In terms of r. Okay, cool. Let's have our pens ready. So it will literally be 3.1. You have t1 plus t2 equals 2, ne? But they said your t1 is equal to a, ne? Right? So a plus t2 equals what? Equals 2. But you know the relationship between t2 and t1 in the quadratic, in the geometric sequence, the ratio between the second term and first term is r. That's what you know. It's like the ratio, it's constant, ne? Yeah. So that means your t2 is equivalent to r what? T1 times r, ne? Right? That's what your t2 is equal to. Therefore, t2 is equal to, instead of placing t1, you just plug in this guy over here, right? So it literally be what? Be a times r, right? Right. So that's your t2. Then you go back to this guy over here. Let me use a different color so it's clear what I'm pointing at. You see this guy over here, this equation, in fact, this whole entire equation. This whole entire equation, like when you look at it just here. Oh, I just added thingy. Okay, let's use, yeah, this is much better, né? This whole entire equation has a plus t2. So instead of you in the place of t2, you can always plug what? You can always plug this guy over here, right? Okay, cool. So that means now you'll have a plus, instead of t2, you'll have ar equals 2. You can take out a common factor here, which will literally be your a. Then it'll be 1 plus r equals 2. Then you divide by 1 plus r on both sides. You divide by 1 plus r. Therefore, your a is equal to what? 2 over 1 plus r. Ne? Then you ask yourself, have I solved the question? What was the question asking? What was the question asking? Let's go back to the question. What is the question asking? The question is asking us to write an expression of a in terms of r. Okay, we've done that. Now they're saying, now calculate the values of what? Of a and r. Yeah, this is interesting and very easy. Don't complicate it. You only know an equation. You're given an equation for sum to infinity, but here they have an equation for sum to infinity, but from the third term. But generally, in the formula sheet, what we get given is, we're literally given a sum to infinity, which is this for a converging sequence. This is the sum to infinity that we know. So we can write this like this. We can literally write this like this, 3.2. We know that sum to infinity is equal to, let's go back to our formula sheet. I think it was a over 1 minus r. A over 1 minus r, yeah? Right? But your sum to infinity in this case is term 1 plus term 2 plus the sum that they gave you, because they said if you go to their equation into their formula, they said starting from term 3, starting from what? Starting from term 3, You see n is equal to 3 here. They said starting from term 3 all the way to infinity, you get 1 over 4. But they didn't include term 1 and term 2. But your sum to infinity starts from the first term all the way to infinity. Hence, we are saying here, term 1 plus term 2, then plus the expression that they gave you, which is this n equals to 3, n equals to 3, Tn all the way to infinity, will then be equal to your a over 1, like this, né? Right? What do you know here? You know that your T1 plus T2, they gave you that it's equivalent to what? To 2, né? Right? And this guy over here, this part over here, we were given that this guy is equivalent to what? To 1 over 4. Then that is equal to a over 1 minus r, né? Alright? Okay. That's just us using the information that we're given. So you can either simplify this 2 plus 1 over 4. To avoid wasting time, you can just plug it in your calculator. It's giving me 9 over 4 equal to, okay. You still have a over 1 minus r. Then it's up to you at this point how you want to approach this problem. It's either you want to make your r subject of this formula, or you want to make your a subject of this formula, and then from there you equate that formula with this one. Let's just do that. It's simpler that way, né? You just multiply by, we just multiply by what? We multiply by this guy over here. We just multiply by this guy over here. So it'll be literally multiplied by 1 minus r, and on both sides 1 minus r, né? Then this guy will cancel with this guy, right? Then your final equation will be literally a is equal to 1 minus r times 9 over 4, né? But do not forget that in the equation above, you have an expression for a, né? Which is this one. Which is literally this one, né? So you can take this guy, like this expression, and equate it to the other, because they're both equal to a. It's more like you're saying if a is equal to b, but b is equal to c, therefore a is equal to c, because they are both equal to what? They are both equal to b. In this case, this expression is equal to a, and also this expression is equal to a. Therefore, this expression is also equal to what? To this expression, because they are what? Both equal to a, né? Okay, cool. So let's just equate them shortly. It's 2 over 1 plus r is equal to what? Is equal to what? 1 minus r all the way to 9 over 4. Okay. So now it's just us playing with mathematics here. Okay, we can just play with mathematics and maybe multiply by 1 plus r on both sides, né? Multiply by 1 plus r, multiplied by 1 plus r, né? So this will cancel with this guy over here. Then you'll be left with 2 equal to 1 minus r. Can I just group this nicely? 1 plus r times 9 over 4. Okay. At this point, it's giving me the vibes of difference of 2 squares, this one. But let's just solve it in simpler terms. It'll literally, Yeah, so you can multiply like this and multiply like this, but I think you get 1 minus r squared at the end of the day, because 1 times 1 q1, 1 times r, it's r, 1, it's minus, yeah, you get 1 minus r squared. So if you conflicted about expanding brackets, go back to the first lecture. It's outlined there, right? It's outlined there. So you'll have, then you literally have 2 equals to 1 minus r squared multiplied by 9 over 4. Then now it's a matter of grouping the like terms. But how do you group them here? You eliminate this 9 over 4 by multiplying by a reciprocal of it. So it'll be 4 over 9. Eh? So multiply it by 4 over 9. Multiply by 4. Then you cancel this and this, this and this. You literally... Yeah, so varsity has literally taught me to use my head a lot, right? So I generally use my head. You can use your calculator at this point. 4 times 2, it's 8 divided by 9. So you'll end up having 8 over 9. Eh? You'll be literally having 8 over 9 here on the other side. 8 over 9 equals 1 minus r squared. Yeah. And then you can literally do it like this again. Take this one to the other side. What I normally like doing, but let's just do it in simpler terms. Take 8 over 9, then minus 1 equals minus r squared. You should be aware that, I'm just playing with maths now. So it's literally, if you don't want to use a calculator, you can say 8 over 9 into, this is 9 over 9, right? Or minus r squared. I enjoy playing with concepts of mathematics. You can use a calculator at this point. Then I'd look for an LCD, which is just 9. 8 minus 9, it's minus 1, equals what? Minus r squared. Then this minus will cancel this minus. Maybe I should use a different color. This minus will cancel this minus. Then now I'm left with what? I'm left with 1 over 9 equals r squared. Ne? Okay. And then, how do you solve this? You just introduce a square root, right? You introduce a square root. So let's go back to our original problem, because now if you introduce a square root is literally plus or minus, right? Generally, when you introduce a square root, you introduce a plus or minus square root. But let's solve it. So that means you literally have your r squared. So no, r squared is no longer existent, because now it's r equals to what? The square root of 3 to the power of minus 2. Let's literally, this is plus or minus, therefore r is equal to plus or minus 1 over 3. So now you'll have to ask yourself, which r is applicable in my system? Let's go back to the question, which r is applicable in my system? Because now you have r that's positive and r that's negative. Let's go back to the original question. What did they say about r? Consisting of only positive terms. So now that means if it only has positive terms, since r is the ratio, you're dividing a positive term with a positive term, you'll always get a positive number. Therefore, the r that's negative doesn't exist in our system. You are now confident enough to say, therefore r is equal to positive 1 over 3. Ne? To determine a, you just sub in the value of r in either one of these equations that you developed. Either this equation over here, or maybe you go back to the part A, or this equation over here, right? This equation over here. So let's plug in to our equation. What I'm getting 3 over 2. I'm getting 3 over 2. I'm getting my A as 3 over 2. So we're done with this. The next chapter will be now us focusing on functions. If you have any queries pertaining this, email us at this email. I'll just write it with my hand so maybe everyone sees it. It says info at destination varsity.com, ne? It's .com. My handwriting is nice, ne? .com. Info at destinationvarsity.com. Be it you want a private tutor, you want extra help, you'll get everything there when you send an email with your queries. Because you can't cover everything on these videos, but we're just giving you a glimpse on how to master this thing. You can literally do as many problems as you possibly can for you to fully grasp what we said here. So it will be literally vital for you to do as many problems as you can, because they can phrase these questions differently. But after these talks after these sessions, you'll be more than prepared to get 100%. But it'll also be dependent on your willingness to get 100, because we can't work for you. You have to work for yourself. You have to do those question papers. You have to do them by yourself, because this is your future at the end of the day.